Hi everyone, I'm Federica from Team 5 and I'd like to start by introducing the group that has worked the last few months to implement an initial idea that has now become a project in its own right, Autonomy. We are 7 people from very different geographical and academic backgrounds. Our heterogeneity has been a strength that has allowed us to reflect on and solve the different challenges required by our idea, social, technical, economic, legal, and cybersecurity related challenges. Our idea is with the autism spectrum disorder and to help caregivers to understand their needs. In the course of our research and meetings with the experts in the field and with caregivers, we realized that some of the biggest problems of these people concern the sphere of social communication and perception of the outside world. Indeed, according to the last edition of the Diagnostic and Statistical Manual of Mental Disorders, the causes of the disorder include difficulties with social interaction and communication, for example, not sharing interests, emotions, and reactions. And on the other side, they have behavior patterns and repetitive interests due to different factors, and we focused on 2 of it. The first one, seamless adherence to routine, which leads them to feel discomfort as a result of small changes, and hyper or hyper-responsiveness to sensory stimuli, or unusual interest in sensory aspects of the surrounding. For example, aversion to specific tactile sounds or textures, fascination or reaction of lights. A lot of research also said that children with the autism spectrum disorder responded more often to a simple humanoid robot and a simple avatar compared to the human. These results support the potential utilization of technological agents for harnessing and potentially increasing motivation to socially relevant behaviors in some young children with autism spectrum disorder. And so we come up with this our idea, that is a combination of device which continuously monitors the patient's stress and also the patient's environment, acquiring image, audio, and physiological parameters. Based on the analysis, the changing state is notified to the caregiver, and with gradual learning, we try to identify the causes of environmental triggers in patient using audio-vision algorithm. When thinking about a project such as this that target individuals, it's necessary to check the degree of invasiveness and to question the ethics behind it. This fits in with what the Ethics Committee believes about the real purpose of medical research, that can never take precedence over the rights and the interests of individual research subjects. Some groups and individuals are particularly vulnerable, so they should receive specifically considered protection. As the Declaration of Geneva of the World Medical Association states, medical research with a vulnerable group is only justified if the research is responsive to the health needs or priorities of this group. And we think that our technology could do that. Thanks to 5G reliability and low latency, we are able to provide patients a device with high quality and protected information. Thanks to the increasing of technology, we will realize customized devices which considers always specific needs of individuals. And with 5G security, for sure, we can improve the safeguard of the privacy, protecting sensitive data of our customers. And now, I leave the stage to my colleague 𝐜𝐡𝐢𝐴 to speak about our technology. Thank you for the attention.
Thank you. Hello, everyone. What does our offer consist of? We provide a starting pack with the 3 elements needed to perform our services, 2 hardware and 1 software. First of all, we offer a device equipped with optical sensor to measure physiological parameters related to the patient's state of stress, an indicator of a possible discomfort situation. The second device consists of a small camera with a microphone to capture the surrounding environment. because elements with strong colors and elements that emit loud and high-frequency sounds can cause discomfort for the patient. As for the environment we are going to investigate, it will be the inside of the patient's home. The third element of the offer is an app that both patient and caregiver will interface with and download to their devices, such as a smartphone or a tablet. The physiological parameters and elements captured from the environment via 5G technology will be sent to the cloud, where they will be processed through different algorithms in order to predict possible stress situations for the patient. Feedback will be sent both to the caregiver, who will be aware of the possible source of discomfort through an alarm signal and text, and to the patient through emoticons and audio, for example, a reassuring and familiar voice, which will allow him to mitigate his stress condition. Next slide, please. As we speak of autism spectrum disorder, the people affected by it are classified into different levels, each of which is characterized by different features and problems, ranging from the less disabling to the most severe. For this reason, our offer must be customized so that it can be adapted according to need at all levels of autism, and thus cover as many people as possible. For this reason, with regard to the measurement of physiological parameters, heart rate, blood pressure, body temperature, and electrodermal activity, the sensor can be embedded into a smartwatch, as in the case of patients belonging to levels 1 and 2, while for level 3 patients who might refuse the smartwatch, a chest band can be used, which one worn underneath the clothing, the patient will forget about it. The data will be processed by the algorithm depending on the device used, and therefore depending on their degree of accuracy. Next slide. The functions can be performed using the 3G camera, are 3D positional tracking and mapping, spatial object detection, and facial recognition. The camera with the microphone will be embedded into different devices according to the patient's need. For high-functioning patients, it is possible to place the camera on AR glasses, as they are more likely to use them, and there they can receive feedback directly. For patients who cannot wear glasses, it will be possible to place the camera on their clothing, or for those who have the possibility on a robot, which will interact directly with the patient. For more severe patients, it is also possible to use a globe camera, which can be placed by the caregiver in every corner of the house, or fixed cameras, which will cover the rooms of the house that are to be monitored. Next slide. The architecture required for the realization of our project consists of the lower layer is the medical IoT layer, which consists of sensor and camera and microphone, which help us capture patients' physiological parameters and the environment data. The intermediate layer is the Edge Cloud platform, help us by bringing the computing resources closer to user and significantly reduces network latency and improves the performance. The intelligent and self-learning algorithms are hosted on the upper cloud, as we require the high computational resources to process and store the huge medical data captured from the patients and patient surrounding information. The medical data generated from the IoT layer is transmitted to the MEC layer, where immediate tasks like data processing and data analysis occurs on the captured information. We then forward this analyzed data to the upper cloud for storage and further analysis. The updated and the learning models are then pushed to edge nodes for easy network access and analysis. Based on the output of this algorithm, if the patient state is detected as stressed, immediate alert and notification are sent to the caregivers through the app. Next slide. We have three major algorithms involved in our project: environment detection, stress detection, and trigger prediction. For environment detection, this algorithm helps us to detect and recognize the different objects present in the environment. We use YOLO object recognition algorithm to recognize objects in a real-time live video stream captured by the camera. For stress detection, this algorithm helps us to determine the patient's state from the variation in the physiological parameters captured using sensor devices. We use SVM-ML machine learning classifier models for detection. Data obtained from the previous algorithm will be analyzed by word embedding technique TF-IDF of NLP library to try to predict the causes of triggers of stress in the patients. And by maintaining a database of the predicted and identified triggers, we can try to predict the upcoming stress in the patients. I leave the floor to my colleague Aishwarya. Thank you.
Thank you, Costa. We now start focusing on the security involvement in the project. We know security is of major concern for us in our project as we are dealing with the huge medical data. It's important to keep the health records safe from unauthorized use. In our project, security is applicable in three parts: from the IoT perspective, from mobile application perspective, and from the cloud perspective. Next slide, please. So, IoT security consists of security measures taken for the wearable devices like the sensor devices involved in the project. And in order to secure the devices from different possible attacks, we need to provide regular patch updates and also provide awareness to the users. Next slide, please. A major security point in our project are the mobile application software and the cloud application. So for the application side, applications are vulnerable to many attacks, and we need to develop and make regular updates to the mobile application. We have stated some of the major commonly used attacks towards the application in this, and we need to develop a system which can be prevented from all the attacks. Next slide, please. Okay, again, cloud is another major part. We need to take good measures to securely store the data and the health records with better encryption in our system. Next slide, please. Next slide, please. Yeah. We know that 5G has been designed to provide better security controls, and it also provides many security controls to address most of the threats faced in a normal network. So with the deployment of 5G, we believe that most of the security concerns will be taken away in our project. Thank you. Now I give over to Maria Rosario.
Thank you, Aish. So in order to better offer a service for our customers, we had to first analyze their customer jobs, the gains and pains. So starting from our value proposition, as my colleague said, our service will monitor the physiological parameters of the patients, also monitor the environment, and actually analyze and give responses to the caregiver of our patients. So as we are going to determine the customer job, for our service, the functional is absolutely the monitoring and analyzing of the data. As the social, we have to aim to the support and improve of the emotion of our patient, as we aim to understand and better let communicate the patients with the caregivers. So for our idea, we had as game creators, of course, the prevention and the management of stressful situations, as we aim to detect the stress of our patients and so also prevent their reactions. As the pain relievers, we know that there is a difficulty in observation and also the objective data behavior of our partners. But anyway, as the main idea that we can see in the next slide, we resume our value proposition in our business model canvas. As we said before, our service is a system for monitoring patients affected by autism spectrum disorder, but also a service that will aid caregivers to better understand and support them. Starting from our customer segment, we conducted the market research and find that our target customer is, of course, patients affected by ASD, but also their caregivers. As the customer relationship, we decided to have a dedicated personal and emotional assistance, as the severity of the disease we are treating. As regarding to the channels, we will offer our service through web sales and the download of our app. So starting from the other part of our business model canvas, our key partners will be, of course, social and medical associations. That's because, as my colleague Federica said, because there is a strong ethical question behind our project, and we wanted to cure all aspects of this. So we also had some interviews with the families and communities of some parents with the children affected with autism, and that's why our key activities, the main one, are the stakeholder management, but also the data management. As regarding the key sources, of course, the 5G and the IoT will allow our service to work in the best way possible, and also because we put together all our resources in terms of medical, technical, legal, and economics competencies. For the cost structure and the revenue sources, we have a detailed business case built that we resume in the next slide. For the cost structure, we basically have some fixed cost, but also variable cost. The variable costs are mainly the data collection and data analysis. As for the fixed cost, we have all the devices that we have to buy and also provide for offer our basic service and also the premium service. As a matter of fact, here our business case is becoming strong because we conducted some market research. And so how many people in Italy are affected by autism spectrum disorder? That are approximately 600,000 people in Italy. So we assumed a penetration rate of patients that will be our target customer and also will buy the service. As we can see here on the slide, each year our penetration rate will grow thanks to the awareness that our service will acquire. As for the subscription plans, as a matter of fact, the revenue streams will come by subscriptions. We offer one basic service that, as my colleague said before, will provide the basic devices as a camera, microphone, and one just wearable devices. we put as a monthly price 15 euros, but also 40 euros for the initial installment payment. As the premium service, it will differ because for the patients that are affected by autism, maybe the first level, so with not so severity grade of the disease, will offer the premium service, that it's basically the basic service, but with all the devices that can support our idea. So this is our business case, that it's more detailed in our files and documents that we elaborated in this year. But all this data, all these figures have been also validated by experts during our researches. Thank you for your attention. I pass the word to my colleague 𝐻𝐻𝐿.
I think it's my time. I'm Carmelo, I'm not 𝐻𝐻. Anyway, I did the legal part, and the subject we're dealing with is particularly sensitive from legal and ethical point of view, because in such a way our device will be able to monitor the soul of the patient by sensing and showing any emotion they may have. To be brutal, also sexual impulse can be detected. It's therefore necessary that the patient, if he is able, to give his consent. Informed consent is something that we continually grant without paying much attention to it, because the request seems incomprehensible to us. They are long, they are boring, and they are ineffective. We theorized, in the next slide, a system for consent to be truly valid and effective. But for the short time that I will just talk about the patient that we assume are able to express the consent. Our goal is to ask the consent in a way that is funny, interesting, and familiar. Our solution comes from the video games dialogues logic. The consent, in the next slide, the consent will be made through an interactive process between an avatar and the patient. In this way, we will receive more attention from the patient. We could support the information with animation that explain it better. We could create partial consensus contract. For example, the sadness emotion could be shown just to one of the parents. And the big problem are ethical, because it's important that the avatar will not manipulate the patient. It's a big challenge, but we are capable of winning. I think it's time again for the brilliant 𝐻𝐻. Thank you very much.
Thank you, Carmelo. That was a very nice calling back. So we go to the works and the results of the past few months that we did with our project. Next slide, please. We used the NS3 network simulator, which was a widely used network simulation platform for simulating our network aspects. This is the topology scenario we tried to recreate: a remote host, a 𝐠_node and user equipments. And we focused on simulating the video data transmission. Next slide, please. Yeah, so for the simulation, we considered the millimeter wave module with a central frequency of 28 GHz. We have a single cell scenario with a coverage range between 10 meters and 150 meters. We have set the data rate between the 𝐠_node and the remote host as 100 Gbps, and the delay for this particular link was set to 50 milliseconds. The UEs are the main packet generators, and the packet generation rate was set to 50 Mbps. We simulated 3 different scenarios in our use case. Like the first was a single cell with one user node and one 𝐠_node, and this connection was UDP. And the second was a single cell again with one 𝐠_node and one UE, this time with a TCP connection. And the last scenario is the same single cell with one 𝐠_node and 3 user equipments with the same TCP connection. Next slide, please. Yeah, this is the output scenario for the first case, that is the UDP connection. We observe the packets using Wireshark. This is the snapshot of conversation between the UE and the 𝐠_node. The throughput observed in UDP was really good when compared to all the other cases, and the transfer rates of the bits was really high. Next slide, please. This is the same scenario as the previous case, but difference is the TCP connection here. This is the second use case that you observed using NS3. Here we observe a drastic dip in the throughput when compared to the previous scenario because TCP has a lot of handshake and acknowledgements involved. Next slide, please. And you can also see that the round trip time was observed to be between 100 milliseconds and 200 milliseconds. And also the RTT kind of stabilizes after some time, but the delay stabilizes after some time. Next slide, please. Okay, this is the main scenario with the 3 UEs and 1 𝐠-B in a TCP connection. The throughputs, similar to the previous case, was drastically low when compared to the previous UDP. It was much more similar to the previous case, but very low when compared to the UDP case. The next slide, please. Here in this, we observe the RTT. The round trip time for all the 3 user equipments were like this, similar to the previous one, like between 100 milliseconds and 200 milliseconds. And also we can observe that the round trip time stabilizes after some time. The delay stabilizes after some time in all the 3 use cases. Next slide, please. So for the future work with NS3, we thought that we could also try to implement and work on IoT module, which was available with NS3, and try to simulate the sensor part in our project. And also we could try to simulate different environments like with a high user density with more than 1 𝐠-Bs, and also observe user movements between the cells. We could also try to take advantage and try simulating the network attacks, which are also available in NS3, like the DDoS and application level attacks. So this is the NS3 simulation part. And next we go to the proof of concept. Next slide, please. Okay, so proof of concept, again, we focus on the video simulation part that we have in our project. So the equivalent for video simulation in algorithm is going to be the object recognition. So in our work, we focused more on realizing the object recognition part. We had a client server setup. The server setup is where we host the YOLO algorithm, which we used for object recognition. It was hosted on a Ubuntu Linux environment in the virtual machine. The client is the user equipment which streams the video data captured. For this, we used our laptop as the client and used its webcam to capture and stream the video data. We applied the RTSP, which is nothing but the real-time streaming protocol, to stream the data. And for this, we used HappyTime RTSP server software to stream using the webcam of the laptop. At the server side, we captured the data using VLC media player. The algorithm processes the data sent and saves it in a particular file format. The file format can be either between CSV or text based on your requirement. We used text format for further analysis for the other algorithms. We could also try to save the same in using CSV. We realized mainly 2 network scenarios here. An indoor scenario by hosting the algorithm on a VM in one of the laptop, like a local cloud connecting to the client. For this connection, we used 5G CPE along with OpenVPN for the VPN connection. And in the second outdoor scenario, we hosted the algorithm on an AWS server to which the client laptop was streaming the live video. In this case, we connected the client laptop to the internet using 5G cell phone tethering. Next slide, please. The observations, conclusions, and future work. We observed a network latency about 40 milliseconds and for sending the first packet to YOLO and receiving its response. That is the complete network latency. To this, we added the processing time of all the algorithms. We estimate that for a learned setup with available predictions, the overall time for all the processing should be around 90 to 120 milliseconds. We also did a lot of researches on human perception of emotions, and researchers suggest that it takes around 112 milliseconds to 280 milliseconds to perceive other humans' emotions for a normal human. So to conclude, in our case, our estimated overall latency for the whole working of the project, like to notify the stress, is relatively equal to this time. And in some cases, it is more faster than normal human perception. So we believe that for a fully developed 5G connectivity in future with higher processing resources like GPU and CPU at the cloud level, we will be able to achieve even less latency. And our future work, we could further evolve the trigger prediction algorithm by using image embedding models, which can deal with more structured data. This could help us with better stress forecasting and alerting the caretakers even before a real stress happens in the patient. So next slide, please. This was a sample snap we took from the 5G Academy room using YOLO. And in this snap, we can see that objects like a bottle, chair, table, TV getting recognized. Next slide, please. This is an animated scenario of a project, which will better explain it in an animated version. So this is a boy which has a tab and a smartphone and like a camera and the smartwatch, which are major parts of our project. And in case of an external trigger, we can see that his relaxed normal heart rate getting stressed in it. And when we capture all these physiological parameters and we send it to the cloud where it is getting processed, and the right responses and the outputs from the algorithm are then sent to the devices, like either as a notification to the caretakers and as a relaxing, calming audiovisual feedback to the patient, which makes and puts him in a better position from his stressful condition. So that is the animated scenario of a relaxed heart rate and a stressed heart rate. So this is a mock deployment of our app on how the services will be provided to the caretakers and the users. We have two user model in the app, like one for the caretakers, doctors associated with the patient, and the other user model is going to be the user himself, like the patient. When this is the scenario of when a notification is sent to the caretaker when a patient is stressed. And that's the audiovisual feedback. So to conclude, we strongly believe that this is a step towards a better future for the autistic patients. And with time and right resources, this idea can further evolve to fit many other pathologies which could benefit from this technology. And as graduates from different academic backgrounds, we are very happy to have got this opportunity to work on a real-time issue. Thank you very much for all your attention. Thank you.